What's up, my mathletes? How's everybody doing today? That's right, Mr. Muscarella coming at you. And in this video, we're going to take a look at graphing absolute value equations and inequalities. So let's make sure our note sheets are out and we are ready to roll. Now, when we have this, graphing absolute value equations and inequalities, one of the things we're going to want to pay attention to is this thing called the standard form, all right, and the vertex. So the standard form is going to be y equals. Now, sometimes y could be f of x or g of x. It could be any number of different things, but it's going to be y equals, and you're going to have this letter a. And then you're going to have the little absolute value symbol, and then x minus h, and then plus k. So that is going to be the standard form for that. Now, we're going to do another function later on in the year that's going to be very similar to that, so a lot of these characteristics will apply. Now, the vertex. The vertex is going to be the starting point for us when we go to graph one of these equations, and that is from the HK component. So make sure you fill those in into your notes. Now, this V-shaped graph, this absolute value equation, is going to have two slopes. There'll be one that's positive and one that's negative. So when you take a look at these, you want to kind of think about this a little bit. So when we draw a graph, so I'm going to go ahead and draw it in this color right here. So you could have a V that goes like that. So, or you could have a V that goes like that. So those are going to be the two general shapes for the absolute value function. Now, when you do that, one of the things you're going to kind of want to notice on there is pay attention to the slopes, all right? So I'm going to highlight a couple different pieces right here. Like this piece right here has the same slant as this piece right here. Both of those, and you should know from your Algebra 1 days, because there are 4 types of slope, positive, negative, zero, and undefined, and both of those that I highlighted in that, gross, pukey green color, both of those have a slope that is negative. So that's going to be one of the things that you want to think about right there. That has a negative slope on each one of those sides. And then the other pieces, so let's see, maybe this color will be a little bit nicer. So this side over here and this side over here, both of those are slanted in a way where both of those have a positive slope. All right, so that's going to be something that we'll talk about throughout this lesson, is when the slopes are positive and negative, and we'll change those words a little bit later on to be increasing or decreasing. So more on that stuff later. Now, the highest or lowest point on the V, that piece right there, that is where the vertex is. And that's either going to be right up here at the top or right down there at the bottom. And in fact, if it's the top or the bottom, then that's going to be called a maximum or a minimum. And again, more on those things later. And then this third point right here, the graph is symmetric about the line x equals h, the axis of symmetry, and we're going to abbreviate that AOS for that. So that's going to be an important piece right there, and knowing that h value, again, that h is going to come from here, and a little bit on that is a little bit tricky. We got to remember to flip the side of that. So we'll talk about that shortly as we go through these. Now let's go back and kind of do a little bit of Algebra 1 here. Absolute value means the distance from 0 on the number line. So if I'm taking a look at 0, well, the distance from 0 on the number line is just 0. So I'm going to put a dot, add those coordinates 0, 0, which would be right there. Now if I look at -5, the absolute value of -5. So again, if I kind of think about this on a number line a little bit, so here's 0, over here is -5. How far from 0 is that? Well, that is 5 units away. So that would have a value of 5. So even though I go over to -5, so 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, so I'd have that dot right up there. And then 5, if I'm on the other side, so of 0, so 5 is right there in that location. So again, I'm 5 units away. So both of those have the same distance. So the hardest thing on these, especially on a graph, is to count. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So those 3 dots make up the parent function for absolute value of x. So on there, as straight a line as you can draw, go ahead and make that V shape. All right, so that's our parent function right there. And notice, if we were to draw a dashed line going right down the middle, that would divide everything in half. All right, that's our axis of symmetry piece. So let's take a look at g of x. So this is f of x, so let's be sure to label those. Now let's go to g of x. And g of x, notice these numbers 0, -6, and 6 in our table. And notice the a value that's out in front. Now the a value is 1/3, and when I take 1/3 of 0, I still get 0. All right, so that's just plain old 0. And when the absolute value is 6, so again, if I think about it, 0's here on the number line, and then 6 is somewhere over here, that distance is still 6. But I have to take 1/3 of 6. And 1/3 of 6, so some people might think about this and think about it like that, 1/3 of 6, that value is just going to be 2. So I'd have 0, 0, so here's that spot again, 6, 2, so I go over to 1, 2, 3, 4, 5, 6, go up 1, 2. And here's one of the things, too, we want to think about with the symmetry, because I know if I went over 6 and up 2, if I went to the right 6 and up 2 on the right side, I'm going to do the similar thing on the left side, only I'm going to go to the left 6, but when I take the absolute value of 6 again, I will still get 6. So 1/3 times 6, again, is 2. And there's symmetry there, and that's going to be an important piece as we go through. So you go up 6, over 2, and that will be the picture for the absolute value function, 1/3 of the absolute value of x. So that's my g of x. So let's label that g of x. We'll put a little g of x right there. Now, for h of x, now this one's going to get a little bit different. So again, 0 is how far from 0 on the number line? Well, we know that that's just going to be 0. So we're going to put 0 right there. If I have -2 from the number line, I have 0, -2, and 2. So how far is that from 0? It's 2 spaces. So that whole unit is 6. So I'm going to have 3, that a value, times 2, which gives me 6. And then likewise, if I put in the absolute value of +2, 3 times the absolute value of +2. So the absolute value of 2 is 2, and so is the absolute value of -2. Both those give you the same thing, which is 2. And when you multiply either one of those by 3, you end up with a 6. So these are my coordinates here. So 0, 0, so here's my dot right there. And then I have the height I always wanted to be. So I'm going to be -2, so -2, and then I'm going to go up 1, 2, 3, 4, 5, 6, put a dot right there. And then similarly, I'm going to go over to +2 and put a dot right there. So that's going to be this kind of picture going on right like that. And again, we want to make sure that we label that. So that is going to be h of x. And this is where having, colors kind of comes in handy. Although we don't want to make it overwhelming and look like Skittles either, because that's never good. Now this last one, check out this last one, j of x here. So when we have j of x, we have -4 times the absolute value of x. So sometimes another way that you could think about this is have -4 and then put the parentheses, -4 and put the parentheses, and then -4 again, whatever that a value is. And then when I solve for the absolute value of 0, okay, so I got 0, I'm going to have -2 or +2, and I'm going to have -2 over on the left. When I take the absolute value of 0, I get 0. So 4 times 0, that gives me 0. And then I go to -2. Again, how far from 0 on the number line is that? Well, that's only 2 units away. So -4 times 2, I end up with -8. And then when I look at +2, how far away from 0 is +2? And that is just 2. So again, -4 times 2, I end up with -8 once again. So when we draw j of x, so here we are, j of x, there's our dot at the origin, 0, 0. And then -2, so I go over to -2, but this time I go down 8. So, oh my gosh. 1, 2, 3, 4, 5, 6, 7, 8. Boom, right there. And then same thing over on the other side. I'd have +2, -8. And now, here's one of the things that's often, very common to do when you're working with such a crazy grid. If I look at that, I can tell I miscounted over there on h of x. So there's j of x right there. But if I look at h of x, I'm like, bro, man, I counted wrong. And that happens. That's common. So be really careful that you count correctly. So if you caught that mistake, good for you. And if you didn't, that's where you got to pay attention and look at those details. So 1, 2, and then 1, 2, 3, 4, 5, 6. So that should be right there as well as right there. So I went over left and right too far because I just made a little mistake. And that happens all the time when you're trying to put all of these together on one graph. So those are shifts of the parent function. We're going to come back and take a look at transformations in a moment, but that's a good way to get you started. And then be ready to have Desmos out because we're going to play with that too in a little bit. All right, thanks for watching this intro to graphing absolute value functions, and I will catch up with you soon for the transformations part. Peace out.